Now, software engineering questions and answers. First is, what is Software Development Life Cycle, SDLC? This Software Development Life Cycle is the overall process of developing information systems through multi-step process, right from investigation of initial requirements to analysis, design, implementation and maintenance. So if you speak that we have 4 phases or 5 phases, that will not suffice, because our software has a complete life cycle. So this life cycle, right from the inception phase to the deployment or maintenance phase, or with the expiry of the software, the life cycle, the software phases and the software development activities which are taken or undertaken in this whole life is software development life cycle. Draw a diagram for pure waterfall life cycle. This is a kind of model of SDLC, waterfall life cycle model, and this is the simplest model which we have. We have planning, then analysis, design, implementation, testing, installation and maintenance. And the key point in this waterfall is, this is a clean model. Phases are well defined. If requirements are ready and well understood, this is the best model. And the cons are, because once the requirements are being freezed and once you start the process or you start the phases, you cannot go back. So if requirement comes at the later stage, there is no point of changing, because once as the water flows, it will not come backwards. This is not possible. Then we have explained the different phases involved in waterfall life cycle. First is the modeling phase. As you just saw the diagram, in this phase we view the software product as part of larger system or organization where the product is required. This is modeling phase, and this is basically a system view where all the system elements are created. The second is software requirement analysis, SRS is prepared here. So here we have a phase where the requirements are gathered. Requirement gathering is the most important part of waterfall model. The information domain for the software is well understood. The function, behavior, performance and interfacing of the software to be made are determined, and the requirements of the software and the customer are decided upon. And in waterfall, every phase has a deliverable and well defined. Then comes the design phase. Here we define and determine the data structure, the software architecture, the software design, the interfaces, the modules, the procedure that will go into the software, and then the code generation. Based on these design, the code will be generated. Here the actual programming is done to obtain the machine code, and it is an implementation of the design, but in view of SRS. See, this is the Bible. SRS is the Bible, because actually what user want, you have to give that particular thing, that software to the user. Then comes the testing phase and then installation phase. In the testing, whatever you make, there will be some problem, and if you want to be 100% sure, testing is done. The testing is a process that goes hand in hand in the production of the machine code. And there are a number of testing strategies. In the waterfall model, the testing is done only after the code is ready with you. First, unit testing is done, and then integration testing. Unit testing is at module level. Integration is at combine. When you combine the module, this is integration testing. Then alpha testing is to see if software is as per the analysis model. There is the second part, that is a beta testing, is to see if the software is what the customer wanted. So alpha testing is done at the developer end, and beta testing is done at the user side. Then comes the installation. Now finally the software is installed, ported or released to the customer. Then the final phase is the maintenance phase. This is the largest phase of the software lifecycle, and it also involves various activities, important activities. Maintenance can be of various types. To modify the software as per the requirement of the customer evolving, to remove the residual bugs in the software, There are various kind of maintenance. There is a question we will discuss in greater detail. Then what is feasibility study and what are the contents we should contain in this feasibility report? Feasibility is done prior to the software requirement, or this is the first study, whether it is feasible or not. A feasibility study is an initial look at an existing information processing system to decide how it might be computerized or improved, or whether it can be computerized or not, and what are the constraints. So the contents that a feasibility report are the statement of the purpose of the system and defining the scope, and what are the deficiency in current system if it exists. If you are making it from the scratch, it will not be there. The statement of the user requirements, what users suggest, the cost and benefits of the development. This is actually the feasibility, because you are trying to see whether in this cost is it possible to make, and what are the benefits, and the conclusion and the recommendations. What are the purpose of DFD or data flow diagram, entity relationship diagram? Give an example diagram of each. This is often asked question. DFD and ER diagrams difference. So as I go along, please understand it very carefully so that you can be well versed with the differences also. So let me start with this DFDs. As it says, data flow diagram. So data is the key. DFD are a means of representing a system at any level of detail with a graphic network of symbol. What this DFD shows? It shows the data flows, data stores, data processes, and data sources and destination. See, everything involves a data. That is why this is called as data flow diagrams. And the purpose of data flow diagram DFDs is to provide a semantic bridge between users and system developers. Now, if you speak, somebody may understand. But if you show the diagram or show something in the form of bar charts and figures, they will understand more. This is the key idea of data flow diagram. So the diagrams are graphical, that is, you eliminate thousands of words. Logical representation, you can show how you are going to model or what a system does, rather than just physical models showing how it does. Hierarchical means showing the various level of detail. You can just show that these are the inputs, this is the process, this is the output. This is one level. Now you exemplify or elaborate this step. Again you elaborate this step. User may be interested in some part, may not be interested in some part. So everything should be in front of it. Then jargonless. What does it mean? It is allowing user understanding and review. This is a simple example of DFD. You have an external entity. These are the processes. So external entity or the entity is in rectangle. Then these are the process. This is the process flow. This is the direction of process data flow. Then these are the data store shown by two parallel lines. Okay. These 1, 2, 3, and 4. Four symbols are important to DFD. But the most important thing is the DFD should be logical. Whatever you make, it should be logical and should convey your intention to the users. Then entity relationship diagram, ER diagram. This is again a graphical representation of the data layout of a system at high level of abstraction. It defines the data element and their interrelationship in the system. So ER diagram, you have this entity and you show the relationship between the entity. You show the, let me explain it with an example. Now you have this accounts, this is the entity, and it is a relationship that it generates, account generates, so generate is a relationship. Then bills are made of transactions. This is one to many. There are a number of cardinalities and relationships in the diagram. One to one, one to many, and many to many. And all these accounts can have, or entities can have attributes or properties. Like accounts, a name can be there, a type can be there, minimum amount can be there, minimum amount. So this is a sort of, again, the diagram, which is high level of abstraction, and it shows the meaning of or the intent of the developer to the user. Now comes what is data modeling. You can be asked to give examples of data modeling. What is data modeling? Data modeling, as you model, because if you make a house, you have to make a model. So you have to make a software, you have to make a model. And what data is involved, because in software or in computer science term, data is most important. So data modeling is the act of exploring data-oriented structures. Like other modeling artifacts, data models can be used for a variety of purposes. There are different purposes for it. For high-level conceptual models to physical data models. And from the view of an object-oriented developer, data modeling is similar to class modeling. So object-oriented means class modeling. Simple modeling involves class modeling. With data modeling, you identify entity types, whereas the class modeling, you identify the class. So the idea is same. Whichever is the basic building block, you have to model it. And data attributes are assigned to entity types, just as you would assign attributes in operation to classes. And these are the examples of data modeling. First is ER diagram, as we have just seen, because data is involved here. Then entity definition report, entity attribute report, table definition report, and relationship, inheritance, composition, aggregation. This is has a relationship. What is the difference between SRS document and design document? As I mentioned earlier, that various software models, software lifecycle SDLC models, they have deliverables at every stage, every baseline. So SRS document is produced when this requirement phase is over. Design document is produced when the design phase is over. So what are the contents we should contain in this SRS document and design document? So let us see them. SRS document. This is a contract. Please understand, this is a contract between development team and customer. Means you have to have a paper on which both of you agreed. And once this SRS document is approved by the customer, any subsequent controversies are settled by referring to this SRS document. User cannot deny or the developer cannot deny, because things are in written now, this document has been prepared. And SRS document defines the customer requirements in terms of functions, performance, external interfaces, and design constraints. SRS should include, this is very important, because SRS, nobody is going to ask you SRS in detail. They will only ask you what it contains. You should be very specific in answering that it should have functional requirements, non-functional requirements, it can contain user interfaces, it can have system details, somewhat. Then come the design document. This is also very important. The purpose of design is to describe how the enhancements will be incorporated into the existing project, if it is a new, existing project. Otherwise, you can say that the design document creates a framework to code the software. So it should contain samples of the finished product. This could include navigational mechanisms, screenshot, export reports, and component diagrams. Component diagrams are very essential, and then you go to unit level and you design that there are various modeling languages like UML. We'll have question about that also. So we design, and that design is actually a blueprint or a framework for actual coding. What design includes? You can have ER diagrams, entity relationship diagram. This is the higher abstraction level. From that, you can go to the detail level. Then you have data flow diagrams. As I suggested, DFD has various levels, 0, 1, and others. You can go to various levels. Then you have data dictionary. This is also important, because if you are dealing with database management system, you have to now list and explain different types of testing done during the testing phase. Now we have come to testing phase. It involves the design of test cases that validate that the internal program logic is functioning properly, and that program's inputs produce valid outputs. All decision branches and internal code flow should be validated. And unit testing involves the use of debugging technology and testing techniques at an application component level, and is typically responsibility of developers. Now, what is this testing? Now you are trying to verify and validate the software which you have made. Before you go ahead, you have to make a plan. So you are making a plan. Before doing anything, you have to have a proper plan, proper strategy. So you have to have a testing plan. Then you do various testing. So first testing is the all decision branch and internal code. You can say that this is the unit testing. Okay, let me write this. This is the answer of the unit testing. UT. Now we come to integration testing. As the system is integrated, this is tested by the developer for specific components. That is, this is concerned with testing the system as it is integrated from its component, because component we have already checked. Integration testing is normally the most expensive activity in the system integration process, because we are combining the various modules or various components, various classes together. And the focus is on interface testing, where the interactions between subsystems and components are tested, and property testing, where system properties such as reliability, performance, and usability are tested. Well, this is the part of system testing also. But you know, integration and system testing are often asked because they do somewhat similar testing, so there is a difference. Integration testing is mainly focusing on the interfacing of various modules, while system testing is doing what? Let us see. Testing the system as a whole to validate what it means, that it meets its specification and objectives to its users. Now we are not checking about the software, we are checking about the requirements, because we are interested in requirements. The testing of the complete system prior to delivery is system testing. Integration is interface testing of various modules. System testing is the complete system testing before the delivery. So the purpose of system testing is to identify defects that will only surface when a complete system is assembled. Maybe the other parts are working well, when they are combined, they may not well with the external interfaces if some are there. That is defect that cannot be attributed to individual components or the interaction between two components. So system testing, it includes performance, security, configurational sensitivity, startup and recovery. We can say reliability and usability also here, and because recovery and failure are included here. It involves test cases design, validates that an application and its supporting hardware and software, because always some hardware is involved. Components are properly processing business data and transaction. And system testing requires the use of regression testing. Regression testing, as we have just seen, regression technique to validate the business functions are meeting the defined requirements. So, as we have just seen, these testing, and the question being asked is list and explain different types of testing during testing phase. So we start with unit testing, we do integration testing, then we go to system testing. Then there are major, you can say these are all the subsets of major testing. So the major testing are, in the variation of these testings are we have just seen, but the black box and white box are the major testing, because they are not just testing, there are phenomena, these are the ideas. Black box testing, this is the testing without knowledge of the internal working of the item being tested. So black box. So software is a black box for it. For example, when black box testing is applied to software engineering, the tester would only know the legal inputs and what he's expecting out of that software, but not how the program actually arrives at those outputs. He is not worried. It is because of this that black box testing can be considered testing with respect to specification. So this is done, black box testing is done with respect to the software requirement specification. No other knowledge of the program is necessary. For this reason, the tester and the programmer can be independent of one another, avoiding programmer bias toward his own work, because he's aware what is going inside. Then comes the white box testing. Both testing are complementary and supplementary to each other. You cannot say black box is good or white box is good. Both have their own advantages. White box testing, also known as this black box testing, is also known as functional testing. White box testing is a glass box or structural clear box and open box testing. All these testings are white box testing. So white box is a software testing technique whereby explicit knowledge of the internal working of the item being tested are used to select the test data. So if you are planning a test, you have to test and plan according to the actual working of the software. So unlike black box testing, white box testing uses specific knowledge of programming code. Now programming skills has to be there to examine outputs, and the test is accurate only if the tester knows what the programmer is supposed to do. He or she can then see if the program diverges from the intended code, and white box testing does not account for errors caused by omission, and all visible code must be readable. Now, I hope I have answered differences between black box and white box also, because this is the main key question being asked. The other question is, let's explain all the phases involved in the construction phase, build and test networks. They are specifically asking about this network. So in many cases, new and enhanced applications are built around existing networks. So, however, if an application calls for a new or modified networks, they must normally be implemented before building and testing databases and writing or installing computer programs that will use those networks. What I am trying to emphasize here is that you are not generally asked what is the construction phase. You will be given a scenario that okay, now a network is involved, database is involved, because most of the software, I must say, I cannot give a percentage number, but most of the software, they are using and they will use database, or they will use some data store. So this is the question being often asked, that okay, construction phase is there, how you are going to check the database, how are you going to check the networks. So the phase involves everyone, a network designer, a network administrator, assume the prime responsibility for completing this task. And first of all, we have to build a test database, because this database is external. Though we have interface, but it is external to our software. So this task must immediately precede other programming activities, because databases are the resource shared by the computer programs to be written. So if new modified databases are required for the new system, you can now build and test those databases. This task involves system users, analysts, and designers and builders. The same system and specialists that design the database will assume the primary responsibility in completing this task. Database, in the design phase, you have to design the database design also. Okay, this is a part of design. Then you can install and test new software packages and write and test new programs depending upon the requirement. This you can say. Now, what is data conversion and why it is necessary? You will be amused to know that okay, data conversion, what data conversion? Because this is a question which is having a lot of depth in it. So data conversion is the changing of data structure to accommodate new or different needs of the data. Okay. Different operating systems have different application software. Each application normally has its own internal way of saving data. That means data structures. They have their own data structures. There are some standards such as CSV files for databases and RTF files for word processing text. However, these are few and far between and often only save the basic information rather than the full structure. So data conversion again, why is it necessary? I have shown. Data conversion is changing of the data structure to accommodate new and different needs of the data. Then change management. In a software development lifecycle or software processes, change management is an important part. Okay? Computer-based systems are dynamic in nature, and as the business environment changes, there is a need of some changes in the information systems also. So the changes occur not only during the study, design or development phases, the SDLC life cycle. In this process, there are two elements that are essential to manage the change. First is the performance review board, which can make management level decision about system modification, and the baseline modification, which can be referred to determine the extent and impact of proposed modification. Now, the second question can come that who is managing this change? For that, we have configuration, software configuration, a different topic in software engineering which deals with all the changes, controlling and recording all the changes. Now the question comes is, what is user acceptance testing? Because this is very important. You are making a software, it is very good. But for the user, so user acceptance testing, and explain different testings in user acceptance testing, why it is necessary. There are hundreds of testing, right? From sanity, performance, stress, load, ad hoc, exploratory, anything can be asked. But if your ideas are very clear, you are going to answer them very clearly. That I'm sure. User acceptance testing is a phase of software development in which the software is tested in the real world by the intended audience. Okay, we have different testing in this acceptance testing. We have alpha testing and beta testing, right? So alpha testing, this is the software prototype stage when the software is first able to run. It will not have all the intended functionality, but it will have core functions and will be able to accept inputs and generate outputs. So the alpha test usually takes place in developer office on a separate system. In alpha testing, the developer is there and the user is also involved. So you can say, in short, alpha testing is the final testing of the software before delivery, done at the developer side by the user. Beta testing means the beta phase of a software design exposes new product which has just emerged from in-house, that is alpha testing, to a large number of real people, real hardware and real usage. So beta testing is not a method of getting free software long term because the software expires shortly after the testing period. User acceptance testing is used to know if the system is working or not, both clients and in-house. Beta testing, in short, this is the description, but I'll give you a definition. Beta testing is the testing or acceptance testing, type of acceptance testing, which is performed by the user at user side as its own side, because their actual environment will be given to the software. Then comes what are the functional and non-functional requirements. I'm aware this functional and non-functional is quite confusing because when I was learning software engineering, I couldn't understand what is this non-functional. Functional I could understand. So let us see the difference very clearly. Functional means how the system should react to a particular inputs, how the system should behave in the particular situations, and what the system should not do. So functional testing, these are all the functions that should be there, system should perform, and the SRS document, all the requirements of the SRS should be incorporated in functional and tested in functional requirements. Non-functional, constraints on the surfaces of functions, time constraints, constraint on the development process. For example, non-functional means what is the performance, what is the reliability, what should be there, the easiness of working, the maintainability. All those are non-functional, means these are not being stated by the user. But this has to be there. There has to be some inherent property of a software that it should not take much time in loading. It should be very good in view, its appeal should be good. And the user should feel happy when he uses it. These are the non-functional requirements. And I must tell you that this non-functional requirement actually makes your software a hit. Explain the steps involved in prototyping. Prototyping means making a minimum working system or software. What are the steps? We define the goal and purpose of the prototyping. We make plans for iteration, means number, range and evaluations, the dates. We transform the conceptual design because prototyping can only be done when the design is there. The first outline of the user's interface and first synopsis of the user information. Then when we design the proper prototype on the paper. Then let domain experts review the paper prototype regarding completeness and correctness. So a kind of verification is done. Then we test the prototype's usability and we analyze the test reports and we decide on the changes and additions regarding the conceptual data. Then we design an executable prototype with users' information, holding meeting and other discussions. We review and test the usability of prototype, because prototype is also software. It is not just you are showing, and because it will create the first impression to the user. First impression is the last impression. We analyze the test results and we decide on changes and additions regarding the conceptual model, and we decide or design the next prototype, and so on. This is a it's kind of evolutionary process. What is cardinality? Give examples. I've shown you in this ER diagram when we were discussing that question. Cardinality. Cardinality is the number of occurrences that may exist between occurrences of two related entity types. The cardinalities between a related pair of entity types, as I just suggested earlier, 1 to 1, 1 to many, many to many. What is a class and an object? Give the diagrams and representation of class and object, because most of the software are object oriented, or they follow that object oriented paradigm. This question will come. A class is a template for defining objects that specify variables and procedures that operate on those variables. And a class is represented by a rectangle. This is a diagram which shows a typical class in a class diagram. This is a class. Whenever you show or you present it to the user or for your use, this scheme should be followed. This is the class name, and please remember, always a noun, typically name, we characterize this alphabet, so it is typically a noun, and the functions are the verbs which user says. The verbs can be taken as functions, and these attributes are nouns, and classes are also taken like this. For example, if your class has more than one word, you can capitalize the first alphabet of both words and join the two like this. My student and first student like this. This is a list of attributes, and the syntax is like this: list of attributes, attribute colon type is equal to default type, like student name colon string. This is a list of method which goes in here. The syntax is method name, like this method name. You have string. This is the return type. This is the method name, and this is the parameter. So this is a Hungarian method. You can adopt this Hungarian method. So objects are members or instances of a class, which is formed by assigning specific value to the variables in the class. So this is one more example that you have. This is a graduate school of business college. Then these are the university name, number of courses. For one, it can be like this. For the other one, it can be like this. Because this is a class and you are going to make objects from the class. So there can be a number of objects. So you have to specify also. What is generalization? Give an example of generalization. The generalization is an object class which is a superset of another object class or classes. The generalization models that is a relationship. Means, if you make a human being, you say human being is a male, human being is a female, so you generalize it. So, how you generalize? A female is a human being, a male is a human being. So, there is a relationship in between, is generalization. These are always members of the generalization class. Okay. This means that the members of the specialization class have all the same properties of the generalization class. A male will have the qualities and most of the qualities of the human being, and same is the female with some differences, including relationships with other objects as well as the behavior. And a generalization is used when two classes are similar but have some differences. Let us see an example of generalization, formal realization. A customer can be a corporate customer. A customer can be a personal customer. So, corporate customer is a customer and personal customer is a customer. This is a relationship. How it is shown? This is how it is shown. So, in this example, these are the classes corporate customer and personal customer. They have some similarities such as name and address. But each class has its own attributes as well and operations. So the class customer is general form of both the corporate customer and personal customer classes. And this allows the designer to just use the customer class for modules. I do not require in-depth representation of each type of customer because this is Now the basic question: what is software engineering? Software engineering. This is a one-liner, and you have to learn it by heart. The application of systematic, disciplined, and quantifiable or quantifier approach to the development, operation, and maintenance of the software. Again, for the development, operation, and maintenance of the software, the application of systematic, disciplined, and quantifiable or quantifier approach is software engineering. What is a process framework? Process framework, because process are the most important part. If you talk about in later stages, you will be learning about CMMI and ISOs and the Six Sigmas. So most important parts there are processes only. So we have to define this process or process framework. So a process framework establishes foundation for a complete software process by identifying a small number of framework activities that are applicable for all software projects, regardless of their size and complexity. What are the generic framework activities? Generic. Every software will have communication, planning, modeling, construction, and deployment. Define the stakeholders. Now, the stakeholder in ISO, recent version of 2015, and previously it was 2008, so it has been revised. This word has been revised. Now this is known as interested parties. Why it is revised? Because this holds an importance. So we need to define that. Define stakeholder. Stakeholder, anyone who has stake in successful outcome of the project. They may be business managers, end users, software engineers, and support people. Now the other question can be how the process model differ from one another. Because process models can differ in what? Based on flow of activities, the interdependencies between the activities, the manner of quality assurance, the manner of project tracking, the team organization and roles, the work products which identify a requirement identifier. So write out the reasons for the failure of waterfall model. Well, this is a harsh question actually. Waterfall model is still used, and this is a very good model, and all the models are based on these waterfall model only. But if somebody intends to ask, okay, why waterfall model failed? So you need to give an answer. The reason is that real project rarely follows sequential flow. Iterations are made in indirect manner. Difficult for customers to state all requirements explicitly in front, and customer needs more patience as working product reach only at the deployment phase. So the customer should be patient, and no one today has that patience that okay, we'll wait till deployment phase, after 2 years we'll see, after a year we'll see. So this is not going to happen today. That is why waterfall model is not generally followed. This has been replaced with agile developments. What are the drawbacks of RAD model? RAD, Rapid Application Development. Because waterfall model took a lot of time and there were some pitfalls also. So RAD model came. What is this RAD? Rapid Application Development. So it requires sufficient number of human resources to create enough number of teams. Developers and customers are not committed. System result in failure. These are the drawbacks. And not properly modularized building component may be problematic and not applicable when there is more possibility of technical risk. So if risk is involved, RAD model will surely be a problem. Why formal methods are not widely used? Formal methods. This is with reference to the software. Formal methods are quite time consuming and expensive. Extensive expertise is needed for developers to apply formal methods, and difficult to use as they are technically sophisticated. Maintenance may become a risk because formal, there is some ideal situation. The software engineering says that things are ideal, you work around. But when on the actual ground, the things are not followed. The things are changing. They are changing, and it depends on our intelligence, our business requirement, that how we modulate it. So formal methods are a guideline. They have to be there. They should be there, and we need to follow our methods also. With regards to the formal methods, what is cross-cutting concerns? Cross-cutting concerns when the concerns cut across multiple function features. So thank you so much. Hope you got a bit idea about software engineering stuff, but we'll be covering more questions later. Thank you so much.